Quantum computing has the potential to solve problems that traditional computers struggle with, but there's a major issue that prevents it from becoming practical. Qubits are extremely fragile. Unlike normal bits, qubits can exist in multiple states at once, which makes them powerful, but they are also highly sensitive. Even small disturbances can introduce errors, and these errors don't happen occasionally, they happen constantly. This means quantum computers need continuous error correction just to function properly. But error correction in quantum systems is not simple. It requires analyzing massive amounts of data in real time to detect where errors occur and how to fix them. Traditionally, this process has been slow, complex, and often manual. This is where AI comes in. NVIDIA introduced NVIDIA Ising, a set of AI models designed to support quantum computing by handling these complex tasks. The idea is straightforward. Quantum computers handle the actual computation, while AI helps manage and stabilize the system around it. One key part is calibration. Quantum processors need constant tuning because their behavior changes over time. The Ising calibration model automates this process. It takes measurement data from the quantum system and identifies what adjustments are needed. Instead of engineers manually analyzing results, the AI can do it faster and more consistently. The second part is decoding. In quantum computing, errors are detected using techniques like surface codes. But identifying where those errors occur requires heavy classical computation. The Ising decoding model handles this step. It processes the data, detects likely error locations, and enables correction in real time. This is critical because without fast and accurate decoding, error correction cannot scale. Another important detail is usability. These models come with ready-to-use workflows, so researchers can apply them without building everything from scratch. They are also designed to run in optimized environments, making deployment faster and more practical. In simple terms, quantum computing depends on two systems working together. The quantum system performs the computation. The classical system monitors, corrects, and keeps it stable. AI is now becoming a key part of that second layer. This matters because building better quantum hardware alone is not enough. Without efficient calibration and error correction, even the most advanced quantum processor cannot deliver reliable results. So the real progress in quantum computing is not just about better qubits. It is about building systems that can manage them effectively. AI tools like NVIDIA Ising are designed to do exactly that. They reduce manual effort, speed up error correction, and make quantum systems more stable. And that is what moves quantum computing closer to real-world use.